To start the fourth video on object-oriented programming, I'm going to start off with a quandary. Okay, so imagine I wanted to create a bunch of calculators. Okay, each of the calculators below. So we've got a normal calculator, we've got a scientific one, and we've got a programming one. They're all different. You know, they all work slightly differently, but they're very similar. Okay, so if I coded one of the calculators, so let's say the one on the right, it makes sense that I could potentially just copy and paste the code to create this one. And then maybe I copy and paste the code to create that one. Nice and simple idea. But this will have some problems. Can you think about what problems I might have if I just simply copy and pasted the code? One of the problems we would face is quite simply that if I have to change the original class, so the first calculator, and because I found a bug or something like that, I then have to change two other bits of code. That's not very efficient. So rather than do it that way, we can use something called inheritance. So a class can inherit from any other class it wants to. When a class inherits, it will gain access to all the methods and the attributes of that class. When it says gains access, it means it can use the same methods, and if I change any of those methods, then the class that inherits from it will also change as well. So we have a much better way of handling this whole idea of copy and pasting. So an inherited class is known as a child class or a subclass, and the class we inherit from is known as a parent or superclass. Any changes to the parent class will automatically be available to child classes. So if I do make a mistake in my code and I update the parent class, all the child classes will get the benefit of it. Also, if I add any new methods, the child classes will also gain access to those methods as well. It's not a copy, okay? It's not actually copy and pasting anything. What it does is it creates a reference to that code. Okay, so effectively will point the child classes to the parent class's code. So in order to start developing a scientific calculator, we just need to add more methods. Okay, to give you an example, doing SineCosine would be two classic examples. So we're going to look at how we might do it as a copied way of doing it, and also an inherited example. So on the left hand side, you can see I've just copied it. So here I've got my normal methods for calculator, add, equal, subtract, all that sort of stuff. So it's literally copy and paste it. And then I've added two other methods, sine and cosine. On the right hand side, I've done inheritance. Okay, so in order to do inheritance in Python, I will write the name of the class I'm inheriting in the brackets after the class name. Then notice I haven't included any of this code at all, okay, because it's default going to be in there. All I've done is added the two new methods. The code is much shorter, and it also means that if I do make any changes to my original calculator class here, they'll automatically be available in my scientific calculator. So it's much neater, much more an object-oriented way of doing it. So now's a good time to actually have a bit of a pause and to create a scientific calculator. Now, hopefully you have already created a calculator. If not, create a calculator class and then use it to inherit from in order to create a scientific calculator. Have a go at creating sine, cosine, square, and tan. So square, squaring numbers. Have a go maybe doing powers and maybe adding a few other things like pi, logarithms, mod, and div. Okay. If you're going to be using sine, cosine, you need to import the maths module in Python. So if I inherit a method, it will become available. However, sometimes I might not always want to use every single method, or maybe I want to actually change it in such a way that I can just maybe adapt it and add new features to it, etc., etc. Okay. Consider the a programming calculator. So programming calculators work the same way as normal calculators do. However, we can display the results in binary, hex, or just normal binary numbers. So it has the same operations, but when we display our answer, we want to maybe do it in a different way. So we need to be able to change the equals method to either display in denary, hexadecimal, or binary. So we're going to override the functionality of equals. So by creating another equals function, we are effectively overriding it. So let's have a look at how a program calculator could be created. So let's start going through the code in a little bit of detail. So you can see here I'm inheriting from calculator, so that automatically gives me add, subtract, and all that kind of stuff. It also gives me equals. However, equals I want to change. So I want to override the equals method, which is what's happening here. In order to add the functionality of a program calculator, I need to be able to change the base of it. So the base starts at 10, so denary numbers. If I want to set to binary, I change the base to 2. Now, coming back to theory from AS, the base of a numbering system is the number of digits that it has. So in binary, we have a 1 and 0, which is why it's base 2, because it's 2 digits. Denary has 10 digits, 0 to 9. And hexadecimal has 0 to 9 plus A and F, which gives me 16. Okay, so let's change the base. If the base is 10, then I'm going to call the original equals method, and I'm going to explain how super works in a moment. So for now, we're just going to skip over that. But if it's not base 10, then I want to first convert it into the correct base and then display it. That's going to make use of this convert base method, which will convert it into the right thing. It's a recursive method. So I'm not going to explain how it works in detail, but do have a look through it if you don't know how to do it. And also, I've got this translate hex, which will give me A, B, C, D, and E. So sometimes, when overriding a method, we still maybe want to make use of the parent's method. So when we override, we're not deleting the parent's code, okay, in any way, shape, or form. All we're doing is just saying, well, I'm adding extra code to it. That allows us the ability to actually use the parent's original method if I wanted to. To use the parent's original method, we call it super. Okay, we're using a super method. Okay, it doesn't mean that it's that code's better. It just comes from the word superclass. So a superclass is the parent of a current class. So super allows me to run the parent method at any point in your own, okay? And it only works when I'm overriding method. Python syntax is a little bit weird. What we do is we have the super keyword followed by the class name, followed by the object, which might be self, followed by the name of the method we're going to be using. In pseudocode, we simply put the keyword super followed by the method that I want to use. So, coming back to my program calculator a bit more detail, so I've already talked about the base ideas. So we have these new methods added. And then we've got a thing. So now let's have a look at this super method. Okay, so I'm calling super. I'm calling the equals method of the superclass, so the parent class. I'm passing through the name of the class I'm using at the moment, which is the program calculator, and I'm passing through self, which is the current object. So super will call the methods from the superclass or the parent class. So rather than having to write out the code that's in equals, I just simply call it. Now I'm aware that the equals method was really, really simple. I've included it to give you an example or concrete example of how super works. In order to properly understand inheritance, it's best to actually do some coding in it. So create a class called savings account. Savings account is going to kind of encapsulate the idea of a bank saving account, so when you're going into a bank and saving money. So I can deposit money into the bank, I can withdraw money from the bank, I can set the interest rate of the bank, so how much money I'm going to make each year on my savings, and also can add interest each year once I finish my deposits. So start off with, create this class and add some test objects to test it, and then create another class, a subclass, which is called taxable savings accounts. So this one will take off 20% every time I make some interest. So it's going to have two methods. One is setting the tax, and another one is adding interest. It's overriding the add interest method by taking off 20% of the interest